Colloid, or sometimes called a colloidal dispersion. This is a mixture, but it's not exactly a solution. Here the dispersed substance is finely divided in some sort of dispersing medium. And what makes it different than a solution is that the particles are small enough to stay suspended. If you leave a colloid, it's not going to settle out. It will stay in suspension. It'll stay suspended. You don't have to shake it and mix it up. But they're larger than typical solute molecules. So the colloidal molecule particles are typically 1 nanometer to 1,000 nanometers in diameter. And so these are the sorts of things that you might see in a medication or various other things. When they look at colloidal particles under a microscope, they observe something called Brownian motion. And the particles are just kind of jiggling and jaggling around. They're moving around. And that's caused by collisions with molecules in the liquid. So they're bumping into things, and you can actually see them doing that. Because these particles are large enough that you can actually see them with a good microscope. Soap can form a micelle, and micelles can suspend in the water. So you can get a colloidal suspension of soap in water. This is a model of a soap molecule, sodium stearate. And these have a long nonpolar tail. These are carbons and hydrogens, very nonpolar. But then at one end, we have a very polar head. So this is the head, and that's the tail. This is attracted to ions. And what happens is, it's almost like circling the wagons. The polar heads like the water, and so they will stick out here, and they're talking and getting along with the water, but inside is nonpolar. And grease and oils are nonpolar, and they don't wash away with water, do they? I'm going to make a bunch of pies next Wednesday for Thanksgiving. I really like pie, so I always make all the pie because I want good pie, right? I make good pie. You make pie crust, good pie crust, with Crisco. It's like the only time we eat Crisco all year, but lots of Crisco on Wednesday. Well, you get that on your hands, and it's nasty. I mean, it's just greasy. And if you run your hand under the water, it's not going to come off. It just isn't. It's very nonpolar, doesn't like water. So usually the best approach is to take a paper towel and wipe most of it off. But then how do you get the rest of it off? With soap. How does soap do that? Well, these nonpolar tails can interact with the greasy Crisco. And they'll get little particles of the Crisco surrounded by the soap molecules that have a polar head on them, and these are free to move around in the water. So it breaks the grease up into little tiny pieces that can then get washed away by the water. Molecules like proteins are called macromolecules because they're really, really big molecules. They also form colloids. They're particles that suspend in water, but it's not truly a solution because the particles are large. There are lots of examples of colloidal dispersions. Fog, we see a lot of that. Smoke, we see a lot of that. Whipped cream, we see a lot of that on the pie, right? Milk. Now, the milk that you buy at the store is homogenized. They treat it to make it homogeneous. If you have raw milk straight from a cow and you let it sit, the fat rises to the top. And you can skim it off, and then what's left is the skim milk, right? And that doesn't have as much fat in it. But they can treat milk and homogenize it so the fat stays in the milk, and that creates a suspension. An opal An opal is actually a suspension of water in silica glass. So that's kind of neat. But you can have various combinations of liquids, solids, and gases that form these colloids. The Tyndall effect is kind of neat. Colloidal dispersions scatter light, solutions do not. So here we have a beam of light passing through two solutions. And we can see the beam of light in this one, and we can't see the beam of light in this one. Why? The size of the particles. This is a solution. The particles are too small to scatter the light. And in this suspension, this colloidal suspension, the particles are larger and they scatter the light. Here's a picture of, just a beautiful, beautiful place. They have dust too. Look at that. You can see the sunbeam streaming in. Why? Because there's dust in the air. Bless you. Talking about dust made him sneeze. It's in the air, right? And the sun shines in, and it's scattered by the particles of dust in the air.